connect through the edge of technology, sticky tape, power bank, and private iPhone. But essentially, this is what it all is about: sticky tape, crisis engineering. Okay. So actually, I don't see the. Oh yeah, that's the topic. Linux. Yeah. So we went through this xrand error commands to get the second screen working. Or do we have a second screen or only one screen?
No, it's not supported yet.
It's like one screen. Yeah. So the year of Linux on desktops. Again. So Marek Zawadzki, notes on CI/CD from scratch as you build it.
Okay, hi everyone. So before you saw a presentation of pretty complex and detailed issues related to CI, I want to ask you how many of you know how to come to the company, take a software project and introduce CI/CD process to it from scratch with your own hands? Who could do this? Like, raise confidence. Okay, so there are some people who know how to do this, but I'm also happy there are some guys who don't know how to do this, so I hope you can learn from my presentation, from some experiences we've gathered at Mirantis. So I'm a technical team leader in DevOps at Mirantis, and I've been dealing with CI for like a year and a half, so I can't call myself an expert, but I learned something. Before I was working in the HPC department that amazingly is pretty much related to what CI does, like automating jobs, running workloads, and so on. So I hope my experience will help me to share this knowledge with you. So I kind of switched my approach to presentation some times ago, and I don't care if my presentation is pretty, I just want it to be effective. So I always prepare this first slide to let you know exactly what I think you will learn. What was my goal when I was preparing the slides? So my goal was to tell you about the OpenStack way for managing development. So there are many ways, like Allegro way, OpenStack way, some other commercial ways. But I want to teach you this very way of open source and OpenStack CI/CD, and how to reuse it in your environment, and how to plan it, how to implement it and avoid mistakes. This is my objective. And why would you care about all of this stuff? Well, let's speak about the language of pros for you. So it simply will save you time and improve the quality of what you're doing. This is my opinion. Perhaps subjective, but this is what I'm saying to you. Okay, so let's start with simple one-on-one for CI/CD. It's like the very basics. So it's basically the idea that when you create code, you don't merge it to the repository directly. You run it through tests. So if you want to drop your code from your laptop to the repository, you have to go through some tests. If test failed, it means that your code is broken or the tests are broken. You have to fix it and commit again, run the test again, recheck, run the test, and only the tests are green, then you are allowed to merge. You never do this. So this is the base, the concept that I want you to understand. I learned over the last months that it's not really a technology, so that's why the font size is pretty small over here. So technology is important here, but it's not crucial. The CI/CD, in my opinion, is like an agreement, like a culture of the team that everybody conforms to. So if you agree with your guys, with your management, and with your developers that you will go the CI/CD way, then I think it's enough. The choice of technology is secondary. Okay, so here is a 201 course, so a little bit more advanced. You're not a freshman anymore. So you have this code, and again, if you want to drop it from your laptop to the repository to run through tests. But how you do this? Well, you create your private branch in repository, which means that you can keep working on it. It's separated from the master branch. It lives somewhere where other people can grab it, and you run different tests on it. First of all, there is a bunch of tests I would split into 3 categories that you always have to keep in mind if you design CI for many examples of projects. First one, and the most obvious mentioned before, is syntax tests, or like type 8, stuff like that. Second one, if you are developing Python, for example, or unit tests that basically test your code. So you include tests for your code within the code itself. So it's a test written by developers. And the third one is functional or integration or whatever you call it. It means that you actually take and build your software and you run some tests on top of it. So for example, if your software project is web server, you want to actually run this web server and perhaps make it serve like a simple web page and see if it works. So after that, once the basic code passes, you can go through the code review. You can do this in parallel, but I think it's more effective just to let first automated tests prove that your code is kind of good quality, and then pass it to code reviewers. And something that works, in my opinion, is you have regular reviewers, so anyone from the company can just comment on your code. But there is a special group of gods called code reviewers that can influence if your code gets merged or not. So you select your most experienced, seasoned guys in your team or your company and let them decide if the code is good or not. Only if it's good by one or more code reviewers, you allow it to drop to the final repository. So you see, this is just an operation of the previous scheme. Okay, so what are the pros and cons of this approach? Well, first of all, you avoid bugs in the code. You have less bugs, basically, because there are like multiple layers where you detect bugs. You save developers' time. Even in a small project, you can save a lot of time on automated builds, tests. This is all done by software, by the system. And also, it's very important, you introduce a workflow to your guys. You have introduced a way of working with repositories. So it's not just that you create a Git repo somewhere and you tell guys, okay, let's commit code in here. You tell them exactly how they should behave. So don't just merge stuff, run tests first, and they have to do it. So good thing about it is that you can start small. By small, I mean start with syntax tests, for example, and introduce them to the team, let everyone get used to it, and after they are fine with it, you can introduce more tests, like more elaborated, complex tests, like unit tests or functional tests I mentioned before, with dependencies. So you can run one simple job, and if it's successful, run another one. If it's more complex, if it's good, run another one. Because, for example, it doesn't make sense to run functional tests of your entire software if the syntax is wrong. Doesn't make sense because it won't even compile or build. So these are the green things about CI/CD. The bad thing is that it can sometimes slow you down. It can even stop the development for you. So if the CI is broken, basically nothing can progress. So by the agile philosophy, everyone should drop whatever they're doing and fix the CI. This is the idea that we are introducing at Mirantis. So CI must always work, otherwise the development doesn't work. Okay, so let's speak about like a concrete use case. Here are some details about OpenStack project CI/CD infra. So it's about almost 1,000 Git repositories, almost 10,000 Jenkins jobs, and about 1,000 minions. I won't use the name slaves because it's not correct anymore. So about 1,000 of those minions working on the jobs, and it can process about 40,000 jobs per day. I don't even know about the number of developers, but probably thousands of them, or even more. So I assume that if this size of infra is working, it means it's good. It's not perfect, but it's good, so I advertise it. You can go to this page, by the way, and check it by yourself in real time. Okay, so what are the basic building blocks? So you can take those blocks I'm showing here and start from scratch. Even if you have like one physical machine or two machines or a couple of machines, you can take them and build something like that from scratch. So what do we use for this? We use Jenkins, that was mentioned here. Jenkins is just a resource manager. Who never used Jenkins? You never used Jenkins. I saw you were using it today. Okay, so I hope you know what Jenkins basically keeps a notice of jobs. Jobs are basically tasks or scripts that it holds, and it has like a number of machines connected to a number of servers, like workers, slaves, minions, whatever, and it just picks jobs from the queue and runs them. Simple as that. So you need a Jenkins, it can be like a virtual machine, a bunch of machines you connect to it, be it physical machines or virtual machines, whatever, it doesn't matter. You need some kind of repository and code review system. So what is used in OpenStack Mirantis, it's Gerrit. Gerrit is like a web-based code review system. I'll show you screenshot in a moment. And it can be combined with source code repositories such as Git. So it basically gives you a nice front end to the repository. Then you have another piece. Those two pieces are mandatory, by the way. Okay, so that's why they are with bigger font. The rest is optional. So if you want a simple setup, just install Jenkins, put some workers, connect it to Gerrit with Gerrit plugin, and you are good to go. And write jobs, you have CI. And it works pretty good. But if you want to introduce like pipelines and more complex gating, and you want to optimize how your patches are tested, because there are sometimes dependencies between patches, and if you want to test it in a smart way, to make it as fast as possible, then you need some intelligence, and this intelligence was implemented in Zool that does exactly that. It looks into the changes, see the relations between them for you, and run tests in the most optimal way. It also uses Gilman to communicate with our resources in a like standardized way. Another piece that is used is Notebook. There is like a software that manages a one-time use slaves. Like virtual machines that are used only once. So you keep a cluster of those machines. When you run a job, you pick up one of the machines, you run the job on them, and then you destroy the machine. What it gives you is that you're almost 100% sure that the previous jobs did not leave any remains in your environment. So you like cut off one layer of complexity from it, and if you have bugs, you can track them easier. So you can configure Notebook, for example, to keep 10 slaves for you, and so you can run 10 jobs at the same time. The other jobs are waiting in the queue. Each job finishes, it destroys VM, and next VM is created by Notebook. It's pretty simple. And then you need some kind of artifact server that will keep logs, like build results, Docker images, whatever. You need some kind of storage. So those are the building blocks. Here are some screenshots, so you can see Jenkins here. Perhaps somebody never used it, so for those guys, you have a list of jobs here. You have a weather that tells you like what is the kind of situation with this job. Is it usually running successful, or it fails a lot, or it failed a couple of times before? Just quickly let you know if the given job is in good shape or not. It's important, because for example, if you have build jobs and they are green, you can tell that your software does not build in general. So it's pretty good for managers. And you have also slave sealed executors. So good thing is that automatically Jenkins can allow you to set number of executors per slave. So if you know your jobs are small, you can, on one physical machine, you can run tens of jobs. If you know your job is deployment job with a lot of VMs, then you better set number of executors small, like 2, 1, even 1, maybe 3, 4, something like that. And then, of course, you have a nice user authorization in this, so you can log into Jenkins, create users have different rights, and so on. So this is like your control board of your CI. Next one is Gerrit. So this is for code reviewing. This is for letting you know what the shape of your patch. So you commit a patch, and you can very quickly tell from the Gerrit page for this patch what's the condition of this patch. So for example, it's a good example here because it shows a couple of different things. It shows what is this patch about, so there's a description, what files it modifies. So you can click on this and see what was changed in a file. It shows you Jenkins jobs, CI jobs that were run on this patch. So you can see like 4 successful jobs, 6, sorry. And also it can show you the what the code reviewer is. Remember the guys, the super gods, they are here, they can give +2. So 2 guys think that this change is good, which is good. Yeah, so this allows you to control your patches, and the developer usually visits this page many times a day. If something is wrong, like that test doesn't pass, or code reviewer gave negative comments, then usually the developer creates another pass set, which is like another version of this change request, commits it, the tests are rerun over here automatically, which is good, and code reviewers can revisit this patch and review it again. And here is Zool, like a web page of Zool. It actually shows you the pipelines. You have a couple of most important pipelines here. Check is something that happens in the beginning. You create a patch, check jobs are run, and they actually test basic things and tell you if it's worth code reviewing this patch. If yes, the code review is positive, then the job is prepared to be merged and some gate jobs are run, some maybe more complex jobs that checks functionality. And once this passes, the job is finally merged to the repository, and you have the post jobs that can, for example, generate documentation for the automatic. So generating documentation usually shouldn't influence the quality of your code, so it can be included in post job, unless your job is booklet, then you better don't have it as a post job, but maybe as a gate job. Okay, so we could speak about details like how to configure Jenkins or so or something, but you can simply find the documentation. So I want to speak about something more general. Perhaps this presentation will be also lighter for you because of this. So I have to speak what we've learned in a couple of teams that I've been working with in Mirantis, how to approach the problem that I stated in the beginning. So you have a company that develops something, they have some infrastructure, and you want to introduce a nice workflow for developers that is scalable, that you can make more complex in the future, and that improves quality of the code, reduces number of bugs. So in my opinion, those are like the steps that you should follow each time. I haven't followed them for the first time, and the results were really, I would not like to use words catastrophic, but they were really bad. Basically, they messed in the code. So this time, we're developing a CI right now, and I think we are following this path actually for the first time. And it looks good. So first, you need specs. So you can't just introduce CI to your team and that is implemented and tell them, hi, this is CI, let's start using it from day one. It won't work. So you have to first discuss with managers, tell them what are the pros and cons of yet another system in your company or your project, and speak to developers and tell them what are the pros and cons. Because I mentioned on the previous slides that you can slow down sometimes. So secondly, you need to allocate resources. So make sure you have a couple of machines, you have people, like DevOps ops that will deploy those services for you, monitor them and so on, fix if broken. Decide on repositories. Do you create new repositories or you use existing ones? Select which repositories will be covered by CI. CI actions are driven by repositories. Each change to the repository usually triggers an action, a job, a test. So you want to know which repositories you want to test. For example, you have a repository with I don't know, JPEG files. Perhaps you don't want the CI to check the correctness of those files. I mean, you can always use some image recognition to check if somebody has not found illegal images in the repository, but probably not a good case for the CI. Okay, next in step 4, you want to deploy CI services and you want to automate it early, which means that you don't want to just deploy, start using it, and after some time, after maybe a couple of months, think about automation. Why? Because usually in the beginning you will change a lot. Project will change, perhaps you will decide to change your infra and change technology, whatever. You want to have it automated, to do it quickly, or something breaks, you want to automate it and restart from scratch quickly. So I suggest like do a proof of concept, make sure you like it, developers like it, it works, and then automate, use whatever, Puppet, Ansible, whatever you like. Okay, second step, once you have those services deployed, so we have Jenkins with no jobs inside, Garbit, perhaps some other services, you have repositories. So implement by yourself simple tests. Start with syntax tests, they're really simple. They are standardized, like Pet 8, for example. You don't have to implement any real checking by yourself, just launch it. And set that non-voting. Voting, non-voting. Voting means that something influences the merge process. If the job is non-voting, it's just informative. It doesn't influence anything, so it will not get in the way of developers in the beginning. Set them on voting and run training for developers. Show them what's the idea behind, how it works, and tell them to use it, and set a deadline. For example, after 1 week, you switch those jobs to voting. Usually it's enough for 1 week for the developers to fix syntax, to fix style, and then you have a working CI workflow. And step 7, keep improving. Add more jobs, increase number of voting jobs. Generally, in my opinion, all jobs should be voting. If the job is not voting, then it shouldn't be in the CI because it doesn't change anything. Or it's broken, it should be implemented better. So sometimes we are lazy, we don't have good jobs, and we say, let's keep them on voting. No, fix the jobs and set them voting. So, what mistakes can you make in this process? You don't have specs, you don't have common agreement. So what will happen? After some time you implemented CI, you are over here, you implement tests, but somebody tells you, you know what, I thought it will work in a different way. You said something different. You said, well, on the meeting you said it will work in a different way, it will be fast, it will be whatever. No, you want the specs in the beginning, and you want those specs to be approved by your managers and by developers, and then you're free to go with implementation. So if you don't pre-allocate, especially people in the beginning for this, you will fail, because developers will think, I prefer to focus on my tasks, on developing my code. I don't want to work with fixing changes or whatever. So allocate this one person who will work on this most of the time. And if you try to bypass CI in the beginning, for example, a fast ongoing project, and you start to bypass the CI, it will be really difficult to fix it later. So we made this mistake before in Mirantis in one project, and really it was difficult later on because when we introduced CI, the code was so broken that it took really a lot of time to fix it. So it could start passing the CI jobs. And if it passes the jobs from the very beginning, well, you don't have to fix anything. So, if you don't educate folks how it works, they will just struggle. They will keep asking me constantly, they will not get the idea, what's the idea behind CI, so you have to educate guys. You also have to speak to them how this should work. So for example, if you want to run a full deployment job for each change request to the repository, so for each patch, for example, I changed the style of my code, I fix it a little bit, and my manager wants to run the full deployment test. Doesn't make sense. It will slow me down because it will take like minutes and hours to run it. So listen to the developers what they say, what makes sense, what doesn't. Also, if you will be if you keep writing jobs by yourself, you will just create the work for yourself, and developers will still have no clue how it works. So set a rule from the beginning that developers themselves should write tests. So each time they develop a feature, they should write a test for this feature and add it to the CI. It's really not so difficult. This will teach them like discipline. If I write something, I also implement the test for it. And if you don't have the automation for the deployment, if something breaks, well, you have to start from scratch. Maybe you will remember or have some notes how to set those Zool layout file or some options or how to implement jobs, but maybe not. So we better have it automated. Okay, guys, here are some links. Very nice docs, especially I suggest reading about the Zool gating. It's like a really smart idea, and a bunch of docs about OpenStack infra, how it's built, what are the parts of it. Interesting things like third-party CI, for example, that you can vote to upstream projects with your own jobs. So it's really cool if you use an open source project a lot, maybe you modify it, you can set up a CI in your company and have it voting to the upstream gallery, which means that patches of your developers and other developers run through your tests. which is really cool because, for example, you have some specific hardware, you can actually run those tests on this hardware, and in upstream there is no such hardware. That's one example. Okay, guys, it's game time. So, any questions? No questions. Too much pizza. Okay, one question.
Can you provide some practices for integration tests inside of CI environment? I mean, like we have lots of microservices and we want to check if changes work correctly with some other services.
I wish I could ask the same question to somebody. So yeah, we are exactly at this stage right now. So I can share my thoughts. I'm not saying these are the best practices, but what I believe. I think what looks nice from the management point of view and on paper does not necessarily work. So I would prefer to get ugly, unfortunately. And by this I mean those tests must be fast. Otherwise, it's a pain for developers. It really slows down everything. So, like I mentioned before, running full deployment from scratch. So, from like, say you want to run some tests of microservices. So you first deploy VMs with OS. On top of that, you deploy some management framework, like Mesos, for example. And on top of that, you deploy containers. Well, it's nice because you always start from clean, but it will be really slow. So today, I believe those tests, those integration tests, should test only the change that you've made. So you should get ready to have kind of snapshotted or I don't know, kind of cached your environment, so you can instantiate like a cluster, for example, from some snapshot, and it will be like seconds versus minutes, and then just deploy the part that you've changed. I know it sounds very general, but in details, this is how it should work. So, for example, you have a bunch of microservices you mentioned. Your change, your patch only changes one. So we should not recreate the whole stack from scratch. You should have like some kind of snapshot you start and you just push one change, one container change. This is one way. And the second way that I think would work is like to have a shared platform. So have a shared cluster that you never change and run all the tests in shared environment. Of course, it has some drawbacks. So you share first of all, so if one job breaks something, the other jobs will suffer. But at least you don't have to redeploy. So to make it short, I think for those type of tests, minimize redeployment. It will be fast.
I remember some time that the gate was so slow to get to, was getting down to 1-digit number per day of merchant. When I think there was only 7 or 8 matches merged before Jumbo or something. How did they solve this problem?
I'm not sure I can answer this question.
Can you repeat the question actually, because we lost the line.
How they, in OpenStack upstream, how they increase the number of merges per day?
Many.
You guys can help.
Yeah, I can help. But
What's like
again, the question.
The gate was saturated. You only get maybe 7 or 8 pitches a day through the gate. So the Zoom was always saturated. So I was wondering how this situation solved.
Yeah, so the question is like, does it work? Does it work? How? Oh, yeah, of course. Yeah, so OpenStack upstream is like a huge infrastructure, and there's a dedicated team for that. They have their own monitoring, they have their own metrics for that. It's all open, which is interesting. This is a completely different situation than like developing inside of corporation or whatever. So there's a dedicated team, but still this team is like volunteers. So the main principle is to put as much automation as possible. So Zoom infrastructure, in theory, is using the principle of eat your own dog food. So there's an auto-scaling feature on OpenStack, so this is how it works. works. They just put some metrics in the monitoring, and they just try to auto-scale the testing infra, in theory. In practice, yeah, there's a lot of manual work because it's development, right? So kind of not everything works. But I think if I can say one thing is like automate whatever can be automated. Choose to be going to find that going
I have one question about the testing of OpenStack architecture. Do you use fuzzy tests in your job?
I'm not sure what are fuzzy tests.
We use it for Go, not for Python.
Okay. What it is? It is randomly generating inputs and check output for correct answers. It's fuzzing tests, randomly tests.
Not sure, I don't know answer to this question, so probably yes, I would say.
Again, how it works. So for OpenStack, there's no fuzzy testing. It's just too complex project. So you would need to test every component. So some components, they have internal fuzzy testing. It's not very big, it's just very simple. But OpenStack, well, that's the reference architecture is at least 3 controllers, some compute. So every time you want to do fuzzy testing at the level of infrastructure, is at least 4 nodes to be tested. And fuzzy testing should be combined with flaky tests when you run the workload for some time and check if it changes. It's just crazy. But we did it in Mirantis. We do it in Mirantis. We have this kind of test internally. So when we ship our hardened OpenStack, we have this test. But it's not like in OpenStack in front. It's just huge. Crazy. There's still pizza there.
Okay guys, thanks.